Welcome to Math TV. Today we're solving a quadratic equation by square root method. Like you see, this quadratic equation is not in standard form, which is, the standard form is ax squared plus bx plus c equals 0. So this is 2x squared plus 1 equals 17. That's why we're not using the standard form for this equation. We're going to continue to work and to use the square root. First, we have to get rid of positive 1, which means we have to subtract 1 from both sides. Then 2x squared on the left side equals 17 minus 1 will be 16. And then we have to get rid of 2, divide by 2 both sides. So x squared equals 8. And then to find x, we have to do the square root of both sides. So square root of x squared equals plus or minus square root of 8. I'm doing plus or minus because I know it is a quadratic equation. I see is x squared. I'm expecting to have two solutions. That's why I do plus or minus. The square root of x squared is cancelled, so x equals plus or minus 8. I can write 4 times 2, which is equal like plus or minus square root of 4 times square root of 2. So x equals plus or minus square root of 4 is 2 times square root of 2. So now I found the two solutions. One is x1 equals, with positive, 2 square root of 2. And the other solution is x2 equals with a negative 2 square root of 2. So those are the two solutions, x1 and x2. And I'm expecting always for how to solve for quadratic equation to find two solutions. Now, I'm not sure if these are correct. Let's try to substitute the solution to the original equation and see if I can make the left side to be equal to the right side. Then my solution will be correct. So that means instead of x, I'm going to plug the first solution. So I have here on the left 2 times x equals 2 square root of 2. So 2 square root of 2, that will be squared. And then plus 1 has to be equals with 17. Is that correct? I don't know. I'm going to check. So 2 times 2 square root of 2. 2 squared will be 4. Square root of 2 to the second power, like square root of 2 to the second power is 2 and the square is cancelled, so it equals 2. So 4 times 2. This is what I got from the parentheses. Plus 1 plus 1, is that equal with 17? We'll see. 2 times 4 is 8, times 2 it's 16. I don't know about that, but I'm checking now here. 16 plus 1, is that equal 17? I don't know. I'm checking. 16 plus 1 is 17 on my left side, and then I have also 17 on the right side. Is that correct? Yes, 17 is equal to 17. That means this solution is correct. Now, how about if I check the second solution? Again, I'm going to plug to the equation here, the equation that I have here. It's 2 times x squared. In this case, I have negative 2 square root of 2 squared plus 1 must be equal with 17. Is that equal to 17? Okay, so 2 times negative 2 to the second power, it's negative 2 to the second power, it's negative 2 times negative 2 will be positive 4. So that will be 4. Then square root of 2 to the second power will be 2 because the square root and square has cancelled. So it will be times 2, then plus 1. Is that equal to 17? I don't know. I'm checking. 2 times 4 will be 8. 8 times 2 will be 16. Plus 1. Is that equal to 17? I'm checking. 16 plus 1 is 17. 17 on the left equals to 17 on the right. That means the answer is correct. So I checked. So I don't know if you remember, but what I used here, it's I used the negative 2, square root of 2, all that squared. What I did negative 2 to the second power times square root of 2 to the second power. It is like you having m times n to the power a, for example. That will be m to the power a times mn to the power a. That's what I did. M is like negative 2, n is the square root of 2, to the power a, which is 2. So each of the factors, negative 2 would be to the same power, negative 2 to the second power, and square root of 2 to the second power. That's why I used this kind of formula when I raised that to the second power. So that means the solutions x1 equals 2 square root of 2 and x2 negative 2 square root of 2 are correct. And those are two real solutions. If you enjoyed this video, please don't forget to like and subscribe, and it helps this channel a lot. Thank you.